Alright guys, here's your video for 2.4. Make sure as we go through you're filling out stuff in the margins, and when we get done you do your summary. You're responsible for both of those places. Okay, when you combine a conditional statement and its converse, you create a biconditional statement. So just remember from the 2.2 that a conditional is the normal one, if blah blah blah, then blah blah blah. And the converse is when you swap the order and you say the last thing first, the conclusion first. So basically we're going to be able to say this thing normal going forward and converse when we flip it backwards. So if we can do both, then that is called a biconditional statement. Bi meaning two, so it's like we took two separate statements and smashed them into one. Okay, a biconditional statement can be written in the form P if and only if Q. So take a second and mark down that IFF means if and only if. So you have to read it if and only if so you don't sound like a goofball. So P if and only if Q. So what that if and only if means is it means just what I said earlier. You can say it forward or backwards. If P then Q, so that would be the conditional, the normal way, or you can flip it backwards. If Q then P. So here we're seeing it's the combination of the conditional and the converse smashed together with this if and only if thing. Okay, so we did the symbols in 2.2 where we did the P and the arrows and the not sign and all of that. So here's your symbol for biconditional. It's the double-headed arrow because it kind of means what the biconditional does. You can say it forward, you can go this way, or you can say it backwards, you can go this way. So it's the combination of the conditional with the converse. I can say it forward or backwards, so we put the double-headed arrow on there. Okay, so for the first example, I've given you a biconditional, and you are going to separate it into its pieces. But one thing I want to change here, I want to change that last one to equal. Okay, so two angles are congruent if and only if their measures are equal. So while we get used to this, I'm going to ask you to pull out the two parts, the hypothesis and the conclusion, before you write your statements. Once you get good at that, you don't have to do this step anymore, but we're just still learning. So in this case, what we learned last time, that the hypothesis was everything after the word if. Well, in our case, that if and only if is in the middle. So basically, we're going to say everything before that is your hypothesis. So you're going to write that right there. Two angles are congruent. That's your hypothesis. And your conclusion will be everything after that. The measures are equal. Oh, I did it again. Whoopsies. Sorry. The measures are equal. Okay, so then when we write our conditional, we're just going to say if P then Q. So we will say, let me get here. Let me zoom in so my handwriting's not so horrible. We will say if two angles are congruent, so much for the horrible handwriting, then their measures are equal. Okay, so I just put my conditional, my hypothesis, and my conclusion together in P to Q. If two angles are congruent, then their measures are equal. So for my converse, I'm just going to do Q to P. I'm going to flip that. If two angles measures are equal, then they are congruent. Remember from 2.2 that we still keep that proper noun in the hypothesis, and we move we keep the pronoun in the conclusion. So that's why I said if two angles measures, if two angles, that part stayed in the hypothesis, just so people know what we're talking about. It's not proper to use the pronoun first. Okay, so let's pause right here and you do this part B, this Bobby is a member. You're going to do the same thing that we just did, and then when we come back you can check it. Okay, so here the example that you just did, the hypothesis, Bobby is a member. Conclusion, he has paid $5 dues. So regular conditional, if Bobby is a member, then he's paid $5 dues. And the converse, when we flop it, if Bobby has paid his $5 dues, then he's a member. Okay, so let's go on to something else. Maybe. I'm going to figure this thing out eventually. Okay, so this time we're doing the same process, but instead of them giving us the biconditional and us telling the conditional, now they're giving us the conditional. We're going to do the converse, and then we're going to do the biconditional. So if the date is 4th of July, then it is Independence Day. So let's do, here's our hypothesis and conclusion. So now we're going to flip that for converse. If it's Independence Day, I'm going to run out of room. Then it's 4th of July. Okay, so for the biconditional, remember we're going to put our hypothesis, we're going to put if and only if in the middle, and then we will put our conclusion. So the date is the 4th of July. If and only if it is Independence Day. Okay, so I put my hypothesis first. The date is 4th of July. If and only if went in the middle. And then I could put my conclusion at the end. Then it's Independence Day. Very good. Okay, you guys pause here and try to do B by yourself. Okay, if points lie on the same line, then they are collinear. So the converse would be if points are collinear, then they lie on the same line. Then you can put it or not. It says the same thing with or without it. So I was just running out of space. Biconditional. So points lie on the same line if and only if they are collinear. And because biconditionals truly work forward or backward, you can really write them forward or backwards. Points are collinear if and only if they lie on the same line. Either one of those answers would have been perfectly acceptable. Okay, now we're going to do truth values of biconditionals. So for a biconditional statement to be true, both the conditional and the converse must be true. So because it has to be able to be read forward or backwards, it has to be true forward or backwards. Okay, so let's determine if each biconditional statement is true. If false, give a counterexample. So an angle is a right angle if and only if its measure is 90. So we're going to pull these apart. So if an angle is right, then its measure is 90. And the converse, if an angle's measure is 90 degrees, then it's a right angle. So the conditional is true. If an angle is right, that means it equals 90. The converse is true. If an angle is 90, that means it's right angle. So because the conditional and the converse are both true on their own, then the biconditional is also true. Okay, y'all pause here and you try this one down here. I don't know if y'all says this, but this is supposed to say y squared equals 25. Okay, now go. Okay, so here's your conditional. If y is equal to -5, then y squared is equal to 25. And so then converse, if y squared is equal to 25, then y is equal to -5. Well, that's not true going backwards, because if y squared is 25, we should know if you take the square root of any number, technically you get plus or minus 5. Because 5 times 5 is 25, but also -5 times -5 is 25. So it could either be positive or -5. Whoopsies. So that is where this hits a little snag here. Okay, so the conditional is true and the converse is false, so it has to be able to go forward or backwards, so that didn't happen here, which must mean that the whole statement has to be false. It has to be able to go forward or backward. Okay, in geometry, biconditionals are used to write definitions. A definition is a statement that describes a mathematical object and can be written as a true biconditional. So if for a definition to be true, it has to be able to work both ways, otherwise it's not a definition. So that's where biconditionals come in very handy, because they can help us write definitions. So here we go, same story, different words. A good, precise definition can be used forward and backward. That is why we can use biconditionals to help us, because they are in nature are already forward or backward. Write each definition as a biconditional statement. So a triangle is a three-sided polygon. So we kind of want to break it into what we think is going to be the conditional and what we think is going to, the hypothesis, and what we think is going to be the conclusion. So I'm going to say triangle would be my hypothesis, and three-sided polygon would be my conclusion. So I'm going to stick that if and only if right here in the middle. Now you may have to add some words, some qualifiers, some pronouns, something in the front to make this make sense. So I'm going to say, if a figure, you could say a shape, you could say a diagram. Not if, I'm silly, I'm writing, how about that? A figure is a triangle if and only if it's a three-sided polygon. Okay, so I had to add the word the phrase a figure right there to make it make sense, and then I put my if and only if here in the center, but I could also say that backwards. A figure is a three-sided polygon if and only if it's a triangle. It should work forward and backwards. Okay, y'all pause here and try B. Okay, so for B, same story. I'm going to say all of this, let's switch here. All of this would go in one side, and then that 180 would go on the other. So, I say that an angle is a straight angle if and only if it measures 180 degrees. So that one wasn't straight, this half, that half. I knew I wanted to talk about a straight angle and its measure, so I put the word in the front and the measure at the back. I could have also said an angle measures 180 degrees if and only if it is a straight angle. So either of those would have been appropriate. Make sure you guys fill out your summaries and have stuff in the margins, and we will see you tomorrow.